Hi learners, good morning to you all. Myself Professor S. Krupanidhi, heading the Department of Biotechnology at Vignan's Foundation for Science, Technology and Research, a deemed university located in a rural vicinity, Vadlamudi, Guntur district, Andhra Pradesh, India. Hitherto we have gone through 3 units. The first unit was on the overview of the immune system. Second unit was on the immunoglobulins. The third unit was on the protocols, particularly antigen-antibody interaction. The fourth unit currently we are looking into, that is on the T cell and B cell development. So the T cell and B cell development plays a prominent role in the immune system. Okay, that's what we are discussing now. So here the topic 1 is T cell maturation. We are seeing here the T cell. So we are seeing now here the T cell maturation, T cell differentiation, T cell activation. So these are some of the important events that are discussed in immunology. In immunology, it doesn't go without mentioning activation, because most of the cells that are prevailing in those immune cells, they are all waiting for activation. Okay, activation, how does it happen? When a foreign antigen comes in, then only when it is presented through MSC molecule, T cell gets activated, B cell gets activated. Presentation, who does presentation? It is the dendritic cell that does the presentation. Okay, so that's what here. And apart from that, T cell maturation is another important aspect. See, we have been talking since the beginning, now we have come to the fourth unit. The T cell is said to be the master immune cell. The master immune cell. It regulates all other immune cells. Okay, so that's what if HIV patient is losing T cell, because HIV, what is it called, virus, infects the T cell. As a result, he is suffering from various other opportunistic, what is it called, infections. So that's why the T cell is most important with reference to the immune system. That's what is called master immune cell. Clear? Now let us see the T cell maturation, differentiation and activation, wherein an important aspect here is about that T cell undergoes education. T means here thymus. The cell that is undergoing development in the thymus, that's what called here given the T. Okay, in the thymus there is schooling, thymic schooling. So that this point also I made a reference earlier also. In the thymic schooling, the T cell is conditioned, the T cell is imparted, T cell is educated. Okay, so what is the education here? T cell makes to know, to ignore the self molecules, so that our self molecules are also looking alike with the other self molecules. But our self molecules have to be ignored, otherwise T cell will attack our own cells, so that autoimmune disorders will come. So those points we'll see now. Let's go to the details. Okay, now let us see the video, animated video on T cell development.
Biology arise from the bone marrow, and they arise from the bone, the cells within the bone marrow known as the pluripotent stem cells. So the pluripotent stem cells here give rise to different types of leukocytes, immature or precursors, or even mature ones. And these different leukocytes will then leave the bone marrow into the bloodstream, where they will travel to and migrate to specific tissues, organs, or they will just circulate throughout the body, such as the granulocytes. An example of this is that the T cell precursor, the lymphoid precursor, will travel to the thymus to become mature. The immature B cell will travel to the lymph node to become activated. And then in part 2, we looked at the different organs and tissues within the immune system, and how the different leukocytes migrate or move into these different tissues. The liver, as we have learned, produces important substances for the immune system, such as the complement proteins, which are important in the innate immune system. And then we saw how some types of leukocytes, such as mast cells and macrophages and dendritic cells, move into tissues, such as tissues underneath our skin. And they make up the innate immune cells, because they're the first line of defense, you can say. And then we stopped where the lymphoid precursor, or we can even now say the T cell precursor, migrates into the thymus here. And this is where we start. So in this video, we'll actually see what happens to this T cell precursor. Of course, because this is a T cell precursor, it will obviously become a T cell. However, we looked at the lymphoid precursor when it entered the thymus. And so this lymphoid precursor, it can be programmed. Depending on how it was programmed, it can become a number of different types of leukocytes, including a natural killer cell. But for now, we are just assuming that this lymphoid precursor will become a T cell. So we just wrote this up as T cell precursor. So in this video, we're going to look at the development of T cell from the T cell precursor, from the lymphoid precursor. So we start off with the T cell precursor. The T cell precursor expresses no sign of being an actual T cell. A T cell precursor in the thymus will become either a CD8 T cell or a CD4 T cell. A CD8 and CD4 basically means the type of receptor it will have or it will express. It will express a CD8 receptor or it will express a CD4 receptor. In a T cell precursor stage, it expresses none of these. So we write this T cell precursor as CD8 negative and CD4 negative, meaning it contains no receptors, no T cell receptor CD8 and no T cell receptor CD4. However, in the thymus, the T cell precursor will become a naive T cell, which will then express both CD4 and CD8 receptors. And so we write this as CD4 plus and CD8 plus because it expresses both of them. Now this naive T cell, which expresses both CD4 and CD8 co-receptors, can then become specifically either a naive T cell, which only expresses a CD8 co-receptor, or a naive T cell, which specifically expresses a CD4 co-receptor. So we write this as a CD8 cell or a CD4 cell. So again, this T cell precursor will become either a naive T cell CD8 or naive T cell CD4. You might have remembered me saying that a CD4 cell is a T helper.
So just now, we have gone through animated video wherein the T cell differentiation development in the thymus has been shown. So to begin with, a T cell precursor is having neither of CD8 nor of CD4. The T cell precursor later get differentiated. Okay, so then it becomes a naive T cell. That's what's shown there. The naive T cell contains both CD8 and CD4. You know, we're all familiar what this CD means, cluster of differentiation. These are all the molecules on the surface of the cell. Now this naive T cell later becomes naive CD4, naive CD8. So this CD8 bearing and CD4 bearing naive T cell, double positive. This is called double positive, double negative like that. So the double positive cell, once it gets exposed to MSC class 1 with the antigen, it's going to become CD8. Or if it gets exposed to MSC class 2 with the antigen, it's going to become CD4. So like that, CD8, CD4 are attained in this. Those are the things which we have seen in this particular video. Let us go now. So the objectives of this particular T cell development, differentiation and maturation and activation is this. So to familiarize with the T cells, this is one. The second one is the first one is to familiarize with the T cells. So T cells are nothing but thymic cells. They undergo differentiation in the thymus. Okay, so then to know the maturation of T cells. So that means like individuals also, cells are maturing. To begin with, the cells are naive. The naive cells are coming from the precursor cells, and the naive cells, after having been exposed or getting activated, they are getting matured and activated. That's what we are knowing. And to distinguish between T helper cell, T cytotoxic cell. So hitherto we have been speaking CD8 and CD9. Okay, CD8 means CD8. So that is cytotoxic T lymphocyte. Cytotoxic T lymphocyte contains CD8 receptor. Like that, this is a T helper cell contains CD4 on the surface. On the surface of the cell it is having CD4. These things will be known. Then, to acquire the site of T cell origin. Okay, the T cell, when does it get originated? That also will be known. And again, to appreciate thymic schooling. To appreciate thymic schooling. So, because of this thymic schooling, the T cell develops. The T cell is alloreactive. That is, if any of the antigen that comes from you to me, the antigen comes from you to me, that is reacted by only the T cell, not by B cell, not by macrophages. Okay, so the T cell is alloreactive. So now let us see the expected outcome. The learners of this particular unit on particular topic, T cell development and maturation, we are going to attain these outcomes at the end of this talk. They are the development of the T cell involving positive and negative. Okay, so the T cell is alloreactive. At times T cell becomes autoreactive. At times the T cell becomes, maturing T cell becomes autoreactive. Those things are deleted by negative selection. So the T cell which is not autoreactive, that is going to be positive selected. I will let you know those details now. Okay, MSC restricted development. So the T cell undergoes the development if at all if it is exposed to the MSC molecule, that is HLA molecule. MSC, HLA, MSC and HLA, these are synonymous words, synonymous acronyms. MSC is being used in the mouse, HLA is being used in human beings. Both are Shiva and Shankara like this. Okay, so the HLA is restricted to HLA development. T cell development is restricted to HLA in time. Okay, these are the points which we are going to see now. Now let us see this T cell development. Blood cells undergo the development start. When do the blood cells come? So we are all starting as a single individual, as zygote. We are all starting as a single individual. So we are all starting as a single individual as zygote. Okay, single cell. So zygote doesn't have the T cells; it's only single cell. Once it undergoes the development, okay. So there are amnion, extra-embryonic membranes. Okay, there are allantois, another extra-embryonic membrane. There is yolk sac. Okay, so this is the yolk sac where the blood originates in the developing embryo. Okay, even in the human beings also, even chick bird. So from the yolk sac, it is being distributed to various other regions. But from the yolk sac, it goes to the liver. Okay, from the liver, it goes to 2 points. Please remember this: thymus, and it goes to the bone marrow. So that is the way they took the origin in yolk sac. Later, for transiently, it goes to the liver. From there to the bone marrow. In the bone marrow, all other hematopoietic cells, will develop. But the T cells directly from the liver to the thymus. So this is the route. Those details we'll see now. So that is to know objectives you are seeing, outcomes you are seeing, and the blood. So they develop in the yolk sac and liver. So that's what the yolk sac and liver, that's what I was mentioning. First yolk sac, next is the liver, afterwards the bone marrow. Then the postnatal life, after taking the birth, then they are developed in the bone marrow. Okay, so stem cells differentiate into cells into erythroid, myeloid, and lymphoid. Okay, so these are the 3 lineages that are there in the hematopoietic cell lines. Okay, cells. So out of these 3 lineages, lymphoid gives T cell, B cell, NK cell. So these are the three cells which are having the origin, lineage, lymphoid lineage. Okay. So these myeloid lineages are having what is it called? Macrophages and dendritic cells, basophils and eosinophils and mast cells. Okay. All these things are derived from myeloid or still somewhat. Erythroid is only RBC cells. So like this, hematopoietic system is having the three lineages, of which our T cell comes from the lymphoid system. So now, this was shown here. So this was shown here. This is what called the yolk sac. Okay, from the yolk sac, the arrow is coming like this. It gets into the liver. The developing blood cells I am telling. From the liver it goes to the tissue. This is what happening in the embryo. This is what happening in the embryo. From that it goes to the thymus here in the adult. This is the adult. It goes to the thymus. It goes to the bone marrow in the adult. This is what adult stage. Thymus and the bone marrow. Okay. So in the thymus it undergoes thymic cooling. Particularly the T cell undergoes thymic cooling. And but you see from the yolk sac it also goes to the cloaca. That's called bursa fabricius. This is called bursa fabricius. So here the B cells will undergo the development that you see during the B cell development, not now. Okay. So now, so positive selection, negative selection we have been speaking, let's know. So to begin with the T cell, is the T cell is having both CD8, CD4. So that's what called naive. Here it is naive. That is early, innocent, not familiar. So that is the T cell. So the T cell, if it get exposed to, this is what called self-HLA molecule. This is what HLA molecule here, HLA molecule here, and to this HLA molecule, if you get exposed, the T cell is going to become positively selected. It is allowed to continue. That's what positively selected. Okay, so there are some T cells, it doesn't react. There's no interaction. Some of the T cells, naive T cells, do not interact. Such of them undergo apoptosis. Apoptosis means cell death. Okay, so those are the T cells which interact with the self-HLA molecules. They are going to be selected as positive selection. Those which do not interact, they undergo apoptosis called the cell death. Next point. These are positive selection. Now let us see. In the negative selection, if the T cell binds tightly, to MHC molecule here, this is the T cell, this is the dendritic cell, here binding is tight. High affinity receptor binding. High affinity receptor binding, that is negatively selected. So that's what the positively selected one are having either CD4, CD8 surface receptors. Clear? So this is what the positive and negative selection. Again we see in the next slide. Now this is again one more way of making you to understand how the T cell is undergoing the development. If the T cell is having the tight fit, let us say this is the tight fit with what is called antigen present. This is what the antigen presenting. This is antigen presenting cell, the dendritic cell. So it is having the this is self peptide. Okay, so this is all MSC molecule. So if it is having the tight fit, this undergoes cell death. Okay, if the antigen presenting cell, here this is the antigen presenting cell, here it is a loose fit. Okay, so maturation takes place, it survives, T cell survives. Okay, that's what the main purpose here to explain to you about the negative selection and positive selection. This is another aspect. So the T cell, that means it undergoes the development in the thymus. Thymus is having several other tissues like medulla and epithelium, cortex region. Okay, so our T cell that is there, this T cell interacts with thymic epithelial cells. Thymic epithelial cells. Okay. So every cell is having MSC class 1, class 2 here. So once it interacts with the cell peptide, this is MSC molecule, this is cell peptide, it is interacting. So here is moderate binding. Please make a note here. Moderate binding. Earlier also we told you loose fit. Moderate binding. This is being survived. This T cell is allowed to survive. If the thymic cell, this is MSC molecule, cell peptide, the binding is strong binding. Such a type of the T cells undergo cell death. Okay, so like that it is negative. This is called negative selection, that is called positive selection. These are the words that are spoken here. Now, let us see. So once in the thymus, once the thymus if the T positively selected T cells, they mature, they go to the bloodstream. Okay, from the bone marrow, again the B cells, other cells will come to the bloodstream. And from the bloodstream, this is what we call the lymph node. See, lymph node is an important aspect in immunology. So the blood flows in a good speed. In that speed, our T cells, macrophages cannot encounter the pathogen. So in the lymph node, there is less traffic. There the pathogen is being encountered, macrophages. So that's what the lymph node. In the lymph node, the T cells stay in this region. B cells stay in this region. Okay. So like this, they go and stay in the lymph nodes. In the lymph nodes, they encounter the antigen, pathogen. Okay. So now let us see stem cells. Again, the same thing we are repeating in the form of a text. Earlier I have shown you the pictorial diagram. So stem cells initially do not express CD4. That's what they are double negative. Later they express double positive. And once they come across MSC2 molecule, they become CD4. Once they come across MSC1 molecule, they become CD8. Okay, CD8 means cytotoxic T lymphocyte. CD4 means T helper cells. Now, what are the functions of the T helper cells? T helper cell does enormous functions. Our HIV virus infects the T helper cell. As a result of this T helper cell get infected, we are going to become what is it called? Immune deficiency. Immune deficiency. That's what here called AIDS. Acquired immune deficiency. Okay. Let us see. So make the T helper cell produces IL-2. Remember, interleukin 2 is one of the cytokines, which we covered in the second unit. So the cytokine IL-2, please remember, it is there in the market also. It is being sold. Some of the patients also IL-2 is given. IL-2 makes to recruit more number of cells. The number of immune cells if you are having less at the time of the infection, they make IL-2 cells to become more. The IL-2 makes the immune cells to become more. Okay, so that's what usually done. Okay, it activates B cells also. For activating the B cells, it requires IL-4 and IL-5. The T helper cell produces IL-4 and IL-5. It also activates macrophages by producing interferon gamma. Ultimately, what I wish to let you know is all these cytokines are being produced by T helper cells. So let us see the CD receptor, cytotoxic cell, and this is what cytotoxic cell. So this is what the cytotoxic cell. Okay, so this is what T helper cell. So let us see cluster of differentiation receptors. So it is having, cytotoxic cell is having CD8, the T helper cell is having CD4. Except this, all others are same. This has CD3, CD2, here CD3, CD2, here T cell receptor complex, here T cell receptor complex. That's what we are seeing in the next slide. But only the difference between these two is CD4 and CD8. CD4 and CD8. Okay. So this is LFA means leukocyte function associated antigen. So this is what called the T cell receptor complex. So this is an important aspect. This has been deduced by Nobel laureates, particularly Dickernagel and Dohut. And here T cell receptor complex, it is again belonging to immunoglobulins. Okay, superfamily. It belongs to the immunoglobulin superfamily. That means this region is the constant region, this region is the variable regions. Constant region and variable region. Okay, so that's what superfamily looks like. Okay, here it is having alpha chain, beta chain. And apart from that, CD3 is having gamma chain and epsilon chain. It is also having delta and epsilon and eta chains are there. Now this TCR complex. So this is the complex that receives antigen. Here antigen comes. Here antigen comes. Along with MSC molecule. Antigen along with MSC molecule. Antigen along with MSC molecule. Okay. If there is no MSC molecule, T cell receptor complex cannot see antigen. It totally ignores antigen. Antigen cannot be visible to this T cell receptor complex. It recognizes only the MSC molecule. That's what you have to remember here. So here, antigen presentation. So this is what antigen presenting cell. It's antigen, like a dendritic cell. It becomes a peptide. It presents to the MSC class 2, MSC class 2 through the T cell receptor complex. So like that's what the presentation. So this presentation is made facilitated by having several of other receptors binding. Okay. Okay. Then again, this is the target cell. Here, this is what we are seeing. This is the target cell. Okay, so here it is what MSC class. This is MSC class 1. MSC class 1 is being presented to the TCR complex to CD8 cells. Earlier you have seen MSC class 2 is presenting to CD4. It is CD8. So now it is see. This is MSC class 2 presenting to CD4. Here MSC class 1 presenting to CD8. Okay. Now let us see the summary. Blood cell precursors originate in yolk sac. That's what I have shown you, and liver, and transform the bone marrow during the postnatal life, that is after birth. Double negative T cells become double positive. Okay. Double positive means CD8 plus CD4 plus. CD8 plus CD4 plus. Okay, T cells undergo negative selection and positive selection. Negative selection, when does it happen? When the T cell bind to the self antigens tightly, then that type of the T cell is made to die. So positive selection and develop as 9 T helper cells, 9 TC cells. Okay, then T cells development is MSC restricted, and T cells are master immune cells. Okay, so these are a few questions for you to work at home. This is where from the name T came for T cells. Why do we have to say T? Why not to say ABC? Okay, so indicate the CD is gradually added to developing T cell. And elaborate on T cell differentiation. Explain thymic schooling. What are CD4 and CD8? And explain positive and negative selection of T cells. Okay, please follow this. So in this, let us acknowledge sincerely online resources and public domains from which I borrowed the information to develop this teaching material for you all. Okay, thank you one and all. Go through this T cell development